In this video, we're going to be finding the slope. Given a graph, finding the slope given 2 points, and finding the slope given an equation. So first, let's just define what we mean by slope. So the slope is the change in the y coordinates as a ratio to the change in the x coordinates. We'll often see this as the difference between your y coordinates. That's mathematically how you find the change. And oftentimes it's referred to as the rise over the run on a graph. Now, the variable that's used for slope is m. And that variable comes from the French word monter, which just means to change, which is just a side note. So now let's look at this graph. Now, in order to find the slope, we need to find 2 points. So regardless of the situation, you need to find 2 points. So this is the graph that we used in the intercept video. So we have some nice, easy points to deal with right here. We have the point 0, -6, and we have the point 3, 0. So first, we're going to find the change in y. So our y coordinate is -6 at our first point on the left, and that goes up to 0. So our slope, I'm going to write it right here, our change in y over change in x, our slope goes from -6 to 0, so it increases by 6. And we could see that by this change right here on the graph. It increases by 6 units. Now, notice I counted boxes going up. That worked in this particular case because our graph is scaled by ones. You have to be very careful if your graph is scaled by something other than ones. So for instance, if each box was worth 3, counting boxes wouldn't work in that case unless you ensured that you were counting by 3s. So now we have to find our change in x's. So our first x coordinate is 0, our second x coordinate is 3. So these 2 points change from 0 to 3, so they've increased by 3. And you can see that by this change right here on the graph. It's increased by 3 units. So you can see why oftentimes the slope is considered the ratio of the rise over the run. Now our slope is +6 over +3. We're just going to simplify that. We could simplify that to +2, and that would be our final answer for our slope. Now I just want to make you aware before we move on to the next example that we could have found the slope going in the other direction if we did run first. Oops, I ran a little bit. Sorry about that. I ran a little bit too much. Should have just run 3. And then we could rise 6. You just want to make sure that when you report the slope, you always report the rise over the run, regardless of the order that you do it in. So now let's scroll down and let's look at a situation where we're just given 2 points instead of the graph. So this process is the same. So there are 2 ways that you can do this. The first one is to label the first point x1, y1, and the second point x2, y2. And we could use our formula that I wrote above, that the slope is the difference in the y's over the difference in the x's. So you want to make sure that you use the coordinates in the proper order. So notice when I wrote my formula, y2, x2 comes first. So you want to make sure that when you substitute that in, that you maintain that x2 and y2 come first. So we have -6, I'm going to put it in parentheses as I usually do when I substitute, -6 minus -5 over -3 minus 2 Now, I put these values in parentheses to ensure that I don't lose a sign, and you can see right here that this is very important in this situation because we have two negative signs right next to each other. We could easily just conflate those and look at that as one negative sign, which would be a problem. So in this case, those two negative signs do become positive. So this is negative 6 plus 5, and we have negative 3 minus 2. So now we're just going to simplify this mathematics here. So we have negative 1 over negative 5. Those two negative signs, again, are going to simplify to a positive value. So our slope here is 1/5. Now I said we could do this one of two ways. One way was to use the formula. Another way that I like to do, which not everybody likes to do it this way, but I like to write these points in a table. So this is 2, negative 5, and negative 3, negative 6. And I just like to look at this and ask myself, okay, how do my y's change from negative 5 to negative 6? Well, our y values just went down 1. Well, let's look at our x values. We were at 2, and it went down to negative 3, so it just went down 5. So that means our slope is our change in y, which is negative 1, over our change in x, which is negative 5, and we could simplify that to 1/5. And I just like doing that on the table. I just find it's a lot easier. You're not as apt to make a mistake using the table. Again, it's an option. And now finally, let's look at finding the slope using an equation. So if you're given an equation and you rewrite the equation so that it is in the form y equals mx plus b, where there's nothing else going on in this equation. Okay, there's a coefficient in front of x, meaning there's a number being multiplied times x, and a constant, that negative 5. Then the number that is being multiplied times x is your slope. You can see that they are in the same position there. So there's actually nothing that you need to do here to calculate. You could just find and report the slope as 3. Now be very careful, because if there is an equation that is not in this form, you need to rewrite it so that it is. For instance, I don't have another example here, but let's just say this is example D. Okay, say you're given the equation 2y is equal to 4x minus 8. You first need to get y by itself by dividing everything by 2. So this becomes y equals 2x minus 4. And now that it is in the form y equals mx plus b, we can now see that your slope in this particular example is 2.